Here are the answers for questions 11, 12 and 13 of practice paper 3. So question 11, cumulative frequency. Cumulative frequency is just a posh mathematical way of saying running total. So by the time I've included these two groups, the running total has gone up to 9, and so on. On your graph, draw your cumulative frequency. So the point that often goes wrong here is that you draw the cumulative frequency at the top of this group. So this 9 that I had earlier should be drawn level with 25, not in the middle of the group. So that particular point there, that's my 9 drawn at 25. And then you join the points up with as smooth a curve as you can. Part C, use the graph to find an estimate of the lower quartile. So I know that my running total goes up to 100 people. A quarter of the way through 100 people will be the 25th person. And the age of the 25th person would be about 33 years. You're allowed a little bit of leeway there. Part D is a bit of a problem-solving question. It's asking for the age of people under 65. Sorry, it's the age of people under 52. So we go up from 52 and across, and we work out that 68 of the 100 people in our sample were under 52. So we have to use that to estimate that if 68 out of 100 is under the 52, by the time we scale that up to 1.2 million, 68% of 1.2 million would be around about 816,000, would be under 52 years of age. Find the equation of a straight line. So first of all, I draw myself a sketch and I just plot the points. The first thing I want to do is find the gradient. So to get from -3.5 to 1.2, my vertical change is I've gone down by 3, and my horizontal change is I've gone along by 4. So vertical change divided by horizontal change, it tells me that the gradient is -3/4. Just clean up the diagram again. So I know the gradient is -3/4, and the next thing I need is to find out where it crosses the y-axis. Now there are all sorts of clever ways of doing this with algebra, but the simplest way is just to realize that my gradient means every time I go 1 forwards, I will go 3/4 down, or every time I go 1 backwards, I will go 3/4 up. So if I know I've got this point here at 1, 2, if I want 1 square back, that would take me to the y-axis, and going 1 square back would mean going 3/4 of a square up. So I would hit the y-axis at 2 3/4. So the equation of this line would be y is -3/4 x plus 2 3/4. But the question has asked you to write it this way. So getting this far is going to get you 2 or 3 marks out of the 4. But to write it in that particular way, where all the numbers in the equation are integers. So the first thing I'm going to do is times everything in my equation by 4 to get rid of all the fractions and make everything an integer. And the next thing I'm going to do is move stuff about so that it's in the form they've asked for, with the x's and the y's on one side and the number on the other. So I just move the -3x to the left hand side and it becomes a +3x. Okay, so 4 marks there. Quite difficult, but you should be able to pick up some of the method marks, because the finding the equation of a straight line between 2 points part, the getting this far, is quite a regular question, and you should be okay on that. Show that the 2 lines are perpendicular. Well, you need to have learned that if 2 lines are perpendicular, their gradients will multiply together to give an answer of -1. The Gradient of the first line is 3. I can see that straight away, but the second line hasn't been written in a convenient way. So the first thing I need to do is rearrange it so that it's in y equals mx plus c form, so that I can then read what the m is. So I'm going to move the 2x to the other side first. So I've got 6y on their own. Then I'm going to divide everything through by 6 so that I know what y is. And then I'm just going to do the cancelling and tidying up of minus 2/6. It's the same as minus 1/3. So in the form y equals mx plus c, that's the equation of this line. So I know that for this line, the gradient is minus 1/3. So when I times the two gradients together, the 3 from the first line and the minus 1/3 from the second line, yes, they do give me minus 1, which is enough to prove that they're perpendicular. This is quite a tricky one, but there's a lot of marks here, so do whatever you can and pick up method marks. They've asked me to find the area of triangle ACD. Now, there are more complicated ways you can do this question using the cosine rule and the formula half AB sine C, but because it's so early in the paper, it must also be possible to do it with simpler methods, and that's what I've done here. So the first thing I've read from the question is that it's a regular pentagon. So I can work out something about the angles. The exterior angle is always given by the formula 360 divided by the number of sides. So the exterior angle will be 72 degrees. Now, because I know the exterior angle, I can work out the interior angle, because the exterior and the interior add together to give 180. So now I know what the interior angle is. And because this is a regular pentagon, I know that every one of these interior angles must add up to 108. The next thing I'm going to look at is I'm going to notice that this triangle here has to be isosceles, because the question has told me that the pentagon is regular, so I know the length from A to B must be the same as the length from B to C. So if that triangle is isosceles and I've already used up 108 degrees, that means I must have 36 degrees left over for each of the bases. So that's told me that angle there. And then finally, concentrating on angle C, I know that the whole of this angle must be 108 degrees, because I've worked out that all of the interior angles are 108. And I've worked out that this little bit is 36, so the remaining bit inside my yellow triangle must be 72. So now I've got one angle in the triangle I'm trying to find. And now I'm going to use a special property of the fact that this must be, by symmetry, this must be an isosceles triangle. So for an isosceles triangle, I can slice it down the middle and make two right-angled triangles, which is what I've done in this little diagram here. So this side here in my big diagram is the same as this side here, and then I've sliced it down the middle, because all the way from D to C is 10, so from the middle to C must be 5. And I know the angle here is 72, so I can do a little bit of SOHCAHTOA and find the height of my triangle. And I find that the height is 15.388. Once I've done the height, I can do a half base times height to find the area of that triangle. And I haven't actually written it on here. If I then take the answer for the area of that triangle and times it by 2 to get the area of the whole yellow triangle, I'm going to get 153.8. I think, if I've got my arithmetic correct.